One, it has many applications, and also it's cheap to study, and also to just publicize the results. Because we are using a tree. Tree is grown everywhere, so with few resources, it's natural resources, we just predict the other natural phenomena, just like climate change. First thing is just it increases the drought frequency. If you see back the history, before a decade ago, that the dry frequency is once in 10 years. But after recently it become 2 to 3 years. If the frequency starts to increase, that means increasing the problem of the people there. In terms of accessing food, in terms of accessing waters, including their animals, most of them are pastoralists. The people are not in position to have reserved food for the successive years. Once rainfall means just failure in food production. If that means a lot of people get into a chronic food shortage. That the problem of global warming is not unlike European. It's like modernized farm, you have the storage. Even if the rainfall is not coming at the proper time, you have still a chance to produce by irrigation. But in Africa, there is no just like mechanized farming systems. All things depend on rain. If the rain is just stopped, that is the human is facing a big problems. That's why Africa has become, or sub-Saharan Africa, including Ethiopia, it's very vulnerable to climate change. So the problem is not only global warming, and also we don't have data to predict how it will affect. So if we cannot predict the impacts of global warming, we cannot be ready to adapt. To adapt, we need just like a data, weather data, climate data of long term. But if you see the total Africa, there are few climate observation or just like climate or weather observation stations. If they have, there is only have a short term, marine maximum 30 to 40. But what we can use is here the tree. The tree grow everywhere and live long. At the same time, they record the past history that is related with rainfall. That means they do have information packed inside the tree. Then what we are doing is unpacking that pattern, the climate pattern which is stored in the tree, and give it a meaning. So in order to have additional data of climate, that means past, maybe if the tree lives in 300 years, that means we can even extract 300 climate information of the area. In this case, we can be able to model, we can use to predict the impacts of climate change. We can use it for adaptation strategy. We can use it to manage dams even. Because whenever you have long data of hydro-climatic data, that means your prediction of managing water resource, forest resource, any other resources, and also to predict the impacts of climate change and to strategize to minimize the impact of this drought, that's really helping data. Whenever you have a big data, that means prediction is going to be precise and precise. It can apply on water management, it can apply to forest production, it can be applied just like the prediction of climate variability for a long term. It can also be useful just like for the regions, because that area is Ethiopia at the center. There are lots of water resources coming from Ethiopia and drained to the lowland. If we use this data and could nicely predict how to manage, how to use, that means it's still applicable and helpful for the other regions, nearby regions. The method what we use can be applicable everywhere, because the tree grown everywhere in parts of Africa, our methodology can be applied there. Science makes the decision makers to make a decision based on real information. If they don't have real information, they can decide actually are they like, but their decision is not going to be useful. Science is just one half part of the activity in climate change, and the decision maker should come up to fulfill just the whole percentage.